Welcome to Module 7, Solution Architect Series, Model Data for Power Platform Solutions. This module is part of the Solution Architect Design Microsoft Power Platform Solutions learning path. Let's get started. Solution Architect Series, Model Data for Power Platform Solutions. Introduction. Solution architects are responsible for the overall high-level design of the data model for the solution. It is imperative that solution architects understand the capabilities of Microsoft Dataverse when they are designing the data model for the solution. This module addresses the trade-offs for modeling data in Microsoft Power Platform solution.
As a solution architect, you will lead the efforts for designing the data model and establish a high-level data architecture for the project. The data can be in Microsoft Dataverse, a data lake, or even a third-party system that you communicate with using a connector. Beginning with a well-thought-out and properly defined data model is key for a successful line-of-business application solution. It is important to establish a data model that can be extended by the individual design teams and communicate this design with the teams. As the project progresses, you will review and provide feedback as the data model evolves during the more detailed design of specific solution features. The process of data modeling itself is where you evaluate the needs of the system and organize the data into logical pieces of related information. In Microsoft Dataverse, those logical pieces are called tables. You might sometimes hear these called entities as well. You can then further define the tables with columns of more specific data. But most of that work will occur as part of the detailed work later in the project. Tables can be related to one another, then you can define behaviors between these related tables. These are referentially related tables, tables with parent-child behaviors, and so on. There are many ways to evaluate, plan, and share your data model. For me, I'm a three-dimensional thinker. I see the data models in my head with their relationships and their behaviors. All of this moving around in my head as I read through the requirements and begin planning. Teams can informally draw a data model in a team meeting on a whiteboard. You can then take that and make a more formalized version of it to share with additional team members and stakeholders like this one. These are both the same data model. In this module, you will explore in more detail how to do data modeling, and you will also have a chance to practice data modeling in the exercises.
Data Modeling Overview. A data model is a visual model that shows how data flows through your system and how different entities relate to each other. Data models define the relationship types between entities and abstract a database to a straightforward visual representation. For solutions that are based on Microsoft Power Platform, the data model is crucial to the design of the solution because it will affect app design, especially model-driven apps. Solution Architect's role in data modeling. With data modeling, the solution architect's role is to lead the data model design effort to establish a high-level data architecture for the project, establish a data model that can be extended by the individual design teams and communicate the design with the teams, review and provide feedback as the data model evolves during detailed design of solution features, work with multiple options. Data modeling can be difficult, and having experience with many different projects will increase your data modeling skills. Often, a clear, correct answer won't be provided, and many possible options might be available. Solution architects need to make the best choices with the limited information that is available, which is part of being a solution architect. Next unit, Common Data Model. Common Data Model. The Common Data Model Standard defines a common language for business entities that cover the full range of business processes across sales, services, marketing, operations, finance, talent, and commerce for the customer, people, and product entities that are fundamental to a company's business processes. The goal of the Common Data Model is to enable data and application interoperability that spans multiple channels, service implementations, and vendors. Common Data Model provides self-describing data, structurally and semantically, enabling applications to read and understand the data. Common Data Model Overview. Common Data Model is a standard and extensible collection of schemas, entities, attributes, relationships that represent business concepts and activities with well-defined semantics to facilitate data interoperability. Additionally, Common Data Model has the following features. A shared data model allows applications and data integrators to interoperate through a unified definition of data. A rich metadata system with standard entities, relationships, hierarchies, traits, and more. Originated from Microsoft Dynamics 365 CRM apps that are shown as open source in GitHub with over 260 standard entities. Multiple systems and platforms currently implement the Common Data Model. Internal and external partners, including Dataverse, Microsoft Power BI Data Flows, Microsoft Azure Data Services, Informatica, and more. Where Common Data Model is used. When you provision a Dataverse environment, the core schema in Common Data Model is used to create the tables, columns, and relationships in the Dataverse database. Some core tables include account, contact, lead, and task. When you deploy a Dynamics 365 app, such as Sales, the tables are created from the core schema, the CRM base schema, and the sales schema. The storage format that is defined by Common Data Model is also used in other tools such as Data Flows, Power BI, and Microsoft Azure Data Factory. This feature permits interoperability between these tools, which helps make creating enterprise solutions simpler. Microsoft Industry Accelerators. For industry-specific tables, consider using Common Data Model. In addition to the metadata system, Common Data Model includes a set of standardized, extensible data schemas that Microsoft and its partners have published. This collection of predefined schemas includes entities, attributes, semantic metadata, and relationships. Microsoft is working closely with representatives from various industries to make Common Data Model more relevant to them by creating industry accelerators. Industry accelerators are foundational components with Microsoft Power Platform and Dynamics 365 that enable ISVs and other solution providers to quickly build industry vertical solutions. The accelerators extend Common Data Model to include new entities to support a data schema for concepts with specific industries. Microsoft is currently focused on delivering accelerators for the following industries: automotive, financial services including banking and insurance, education including higher education and K-12, non-profit, manufacturing, media and entertainment. For more information, see Overview of Industry Accelerators. Next unit, Data Modeling. Data Modeling. Data modeling on Microsoft Power Platform examines the whole data architecture picture and includes a logical glimpse of data from Dataverse, data lakes, and external sources by using connectors. Multiple types and standards for data modeling are available, including Unified Modeling Language, UML, IDE F1X, and others. Specific data model standards are beyond the scope of this unit, but data models for Dataverse data structures generally fall into two general categories: logical data models and physical data models. Entity relationship diagrams. Logical data models are high-level diagrams that show how data flows through the system. Logical data models are frequently put together at the beginning of a project during discovery and before all columns have been defined. Generally, the logical data model diagram uses the business names of the entities, not the schema names. Logical data model diagrams depict the flow of data in a solution without worrying about the physical implementation. Physical data models are lower level than logical data models. They generally include column-level detail and, more precisely, design relationships. The physical data model is created when the high-level logical design is translated to physical entities. Physical data model diagrams should include showing Dataverse, Microsoft Azure Data Lake Storage, Analysis Services Connector, or other data store boundaries. You can also create object diagrams. Object diagrams show what you want to know and, more importantly, what you don't want to know. Object diagrams need to be done in modeling sessions and with domain experts. Data modeling strategies. Consider the following guidelines for building a data model. Start with core tables and relationships. Often, teams will become sidetracked with the whole problem. However, it's ultimately easier to solve small parts of the challenge and then look at it holistically later. Over-normalization. Teams that have people with strong data architect backgrounds tend to build a Dataverse data model as if they were building a traditional SQL Server database. This approach can lead to poor user experience and requirements for extra processing. Solution architects need to work with such people to determine the cause and effect of relationships in the user experience to help them understand the goal. Current needs. An excellent feature of Dataverse is that it can be incrementally built by using an agile process. However, having insight into the short and long-term future helps establish a foundation. Make sure that you don't become immersed in trying to identify every future requirement that you can think of. Proof of concept. Dataverse simplifies the process of creating an environment, trying a model, throwing it away, and trying again. Occasionally, challenging two teams with the same data modeling problem can produce useful results. Data model influences. The data model can be influenced by a series of factors. Security requirements. Solution architects should always push for simplification, but these simplifications can drive requirements onto the data model. User experience. A concept that's easily forgotten is that as you add normalization and relationships, you will create new constructs that users need to navigate in the apps. Data location and retention. Not all data is allowed to be stored. Often, data from services can't be cached, and companies have internal policies that govern use of data. Some data is protected by government laws or might have specific requirements for storage, for example, identifiable information, credit card numbers, and so on. Self-service reporting. If it takes a data architect to navigate the data model, chances are many tools from Power BI and export to Excel will be less valuable to the user. Most self-service features of Dataverse allow navigation of one level of relationship. Existing systems. Consider whether the systems are legacy systems, if an API exists, or whether the data can be accessed or copied. Localization. Assess whether the requirements are multi-regional, multilingual, or multi-currency. Next unit. Choose a data source. Choose a data source. This unit compares data stores for your apps. Location of the data. When designing your solution, you should consider the existing data sources for your solution. New data. If your app is creating data that doesn't already exist, such as in situations where the existing business process was done by using paper, we recommend that you store the data in Dataverse. Read-write from an existing system. Data that reads or writes from an existing system is a type of data where you need to retrieve the latest information from an existing database or system. In these cases, data needs to be requested at the time when you need it. Make a copy of existing data. In situations where original data should never be modified or overwritten, you can copy the data to another data store such as Dataverse. This approach ensures that the data in the original system won't be changed, yet your app can work with it. This scenario is common when you are working with data in accounting and revenue-related systems. Where to store data. Data modeling on Microsoft Power Platform should look at the whole data architecture picture and include a logical look at data from Dataverse, data lakes, and external sources by using connectors. Dataverse. Dataverse abstracts your apps from how data is stored. All data in Dataverse is accessed through REST APIs. Currently, the tables in Dataverse are relational tables. Dataverse stores its data in a mixture of stores and formats. Microsoft Azure SQL Database Elastic Pools, Microsoft Azure Cosmos DB, Microsoft Azure Storage, Microsoft Azure Data Lake Storage in common data model folders. Existing data. Apps in Power Apps have three ways of using existing data. Connector. A connector allows the apps to connect to various systems and sources, such as SharePoint, SQL Server, or Microsoft 365, and directly retrieve data from them or save data to them. Data flows. Data flows extract, transform, and load data from another system to Dataverse or Azure Data Lake Storage. Unlike a connector, it fetches data in a scheduled batch. Instead of retrieving the data as is from the data source, You can use Microsoft Power Query Online to manipulate, cleanse and transform data before you store it to the target storage. Virtual tables. A virtual table is a custom table in Dataverse that contains data from an external data source. Virtual tables appear in your app to users as regular table rows, but they contain data that is sourced from an external database, such as an Azure SQL database. Virtual tables are no longer read-only, and apps can create and write data to virtual tables. Choose where to store data. When choosing where to store data from your solution, consider the following recommendations. Dataverse, for transactional data that your apps will consume and manipulate. Azure Data Lake, for data from other systems, read-focused and brought into common data model structure. Connectors, for leaving existing data where it is and accessing other services that make the data available. Next unit, data modeling for Dataverse. Data modeling for Dataverse. When you're storing or viewing data with your app, an important part of the design is the data structure. You should consider how the data will be used in one specific app or screen, in addition to how others will use the data. Referring to your personas, tasks, business process and goals will help you define what data to store and how to structure it. Table types. Dataverse has 3 table types. Standard. Tables where you can store data and add to the navigation in model-driven apps. Most tables that you have created will be standard. Several standard tables are created from the Common Data Model schema in a Dataverse environment. Activity. These tables are used to store interactions such as phone calls, tasks and appointments. A set of activity tables are in a Dataverse database. Virtual. These tables allow you to create the table and columns in Dataverse, but then use an external data source to store the data. To the user, the data appears in their apps like any other data. When you create a custom, standard table, you must specify its ownership. It can be user or team, which is the default option, or organization, used for reference data. For user or team tables, all records have an owner and they support access levels. When in doubt, choose user or team. Organization tables. The record is owned by the organization. All or nothing access. Organization is great for reference data. Custom activity tables. Activity tables are used to store interactions. They have a relationship to all tables that have Enable for Activities set on their table metadata. Activity tables share the same set of columns and share the same security privileges. Rows in the activity tables appear in the timeline on model-driven app forms. In this example, a custom activity table called Donation has been created. A non-profit created a fundraiser application and modeled the donation entity as a custom activity. Advantages for using custom activity tables are that they show up in a list with other activities, can be rolled up with other activities, can create a donation on any table that supports activities. Major disadvantages of using custom activity tables are that they can't configure security different than any other activity, control which tables are related to a donation. Column data types. You need to choose the data type for columns wisely. This notion is especially true for numeric data types because you can't compare numeric columns with different types, and restrictions are placed on the data types for calculated and roll-up columns. After a type has been chosen, it can't be changed. Yes/no data type. Ensure that you never need more choices. File and image. Allows you to store file and images inline in Dataverse. Customer data type can be either contact or account. Lookup or choice. Make sure that you choose the best one. Date, time. Make sure that you choose the appropriate behavior. Numeric. Many to choose from, so choose wisely. Choice table versus lookup table. How you decide between using a lookup table or a choice table depends on the circumstances. Use a choice table when you want a table that only stores label and value as a key pair value, has localization built in, is treated as a solution component, doesn't have a built-in way to retire values, has UX that works to about 200 items, can be filtered by using JavaScript, is stored as a whole number on the row. Use a lookup table when you want a table that can store other data in columns on the row, requires you to build localization, is treated as reference data, supports an inactive state, has UX that scales to many items, can filter by views and security, is stored as an entity reference. Storing other data on the lookup table allows you to access when you are running workflows or other customizations that reference the data. For example, a related property can be used in a check condition. By being a solution component, a choice table handles merge resolution by prefixing the value with the publisher prefix. Adding the values on a choice table requires administrator customizer level access, while lookup values can be changed by a user if they are granted permissions through security rules. The user experience for choices is ideal for small quantity but does not work well for large sets. Lookups provide search type features that aren't available on choices. If you have multiple choice columns that are dependent on one another, this task can only be achieved with form-based script, while lookups can be filtered on other lookups by using configuration. Store file and image data. You have several choices of where to store files and images. Dataverse. Store files and images by using the file and image data types. SharePoint. Used for collaboration, but this option has an issue with security. Security for the files allows SharePoint permissions and is not synchronized with Dataverse row permissions. Azure Storage. Used for archiving and external access. This choice has standalone security, but it can be granted for small periods of time based on a link that is generated for consumption. Valet pattern. Azure Storage can also handle large files. Characteristics of file and image data types. They are good for upload and reference. The security follows record permissions. They are limited by size. Calculated columns. Calculated columns allow simple calculations to be performed on data in a row, and they are calculated on retrieval of a record, have value that is read-only, can include columns from the same row and columns in many-to-one relationships, can include roll-up columns in calculation, can't trigger an event for Workflow plugin or Power Automate. Roll-up columns. Roll-up columns allow aggregations for related rows in one-to-many relationships, and they are calculated on a scheduled basis, minimum of 1 hour, and can be updated on demand by a user. Have a value that is read-only. Can roll up calculated columns. Can use hierarchy of related records. Can filter across related tables. Can't trigger an event for Workflow, plugin, or Power Automate. You can roll up simple calculated columns, that is, calculated columns that include non-deterministic functions can't be rolled up. Relationships. Relationships define how rows are related to one another in Dataverse. Each table in Dataverse has a primary key to provide a unique reference to the rows in the table. In Dataverse, the primary key is a globally unique identifier, known as a GUID. That is generated automatically by Dataverse when a row is created. Relationships are created by adding a reference to the primary key, which is known as a foreign key. In Dataverse, relationships are created by using a column on one table to hold the foreign key value. The foreign key is a pointer to the primary key on the other table. Two types of relationships are supported in Dataverse: one-to-many and many-to-many. One-to-many relationship. The following expense report shows an example of a one-to-many relationship. One expense report with many line items. The preceding screenshot shows the main part of the expense report, which has the employee name and department details. Below the main part are multiple rows of descriptions for each purchased item. For this example, these descriptions will be called line items. The line items have different structure from the main part of the expense report. Therefore, every expense report has several line items. The relationship between the expense report and the line item is an example of a one-to-many relationship. The main part of the expense report is linked to several line items. You can also view the relationship from the perspective of the line items. Each line item can only be linked to one expense report, which is a many-to-one relationship. Many-to-many relationships. A multiple-to-multiple data structure is a special type, and it is used for cases where multiple records can be associated with multiple sets of other records. A good example of a multiple-to-multiple data structure is your network of business partners. You have multiple business partners, customers and vendors, that you work with, and those business partners also work with multiple colleagues of yours. The following sections provide examples of different types of multiple-to-multiple data structures. Example 1. Time-off approval request. The following example shows two sets of data, one that represents the employee and the other that represents the time-off request. Because each employee will submit multiple requests, the relationship in this scenario is one-to-many, where one is the employee and many are the requests. The employee data and time-off request data are related to one another by having the employee number as the common column, also known as the key. Example 2. Purchase approval. In this example, the data structure looks sophisticated, but is similar to the expense report example that was discussed at the beginning of this article. Each vendor or supplier is associated with multiple purchase orders. Each employee is in charge of multiple purchase orders, hence both sets of data have a one-to-many data structure. Because employees might not always use the same vendor or supplier, vendors are used by multiple employers, and each employee works with multiple vendors. Hence, the relationship between employees and vendors is many-to-many. Example 3. Expense reporting. The following example shows an entity relationship diagram, or ERD, that contains multiple tables for an expense reporting solution. Example 4. Track which two benefits that the VIP selected. This example features two VIPs, John and Mary. John has chosen the Wi-Fi and laundry benefits, and Mary has chosen the Wi-Fi and minibar benefits. You can model this scenario in different ways. The first way is to model the scenario as a one-to-many relationship. In this configuration, the benefit record is unique to the contact. No ability is provided to look at all contacts that choose a certain benefit. You can do benefit record security based on the owner of the contact. You can store more data on the benefit record that is contact specific. The relationship is parental to the benefit, otherwise you will orphan the benefit records. The secondary way is to model the scenario as a many-to-many relationship. In this configuration, the associated records from the benefit show all contacts that chose that benefit. Security on the benefit is shared for all contacts, so you will have no ability to tailor each contact. Any attributes on the benefit are shared for all contacts, so you have no contact-specific data. You must use a reference relationship, otherwise you will be removing the benefit from the other contacts. Neither configuration is ideal. The next example shows the creation of a custom interest table to hold the VIP benefits. This configuration adds the ability to store more data on the benefit table that is specific to that contact. It requires more work for the user to connect the records. They now have to create the intersect row manually. Secure benefits individually. Makes querying more difficult because you have no ability to directly access attributes on the benefit table. The following example shows the use of columns on the contact table. This configuration works well for primary and secondary benefits, but would not scale to tracking many benefits. Simplifies querying and makes self-service Power BI easier for users. Follows the same security as the contact record. requires you to create a query that scans primary and secondary benefits if you are querying all users that choose a primary benefit. This configuration is a good example of when the benefit must be recorded for some compliance or statistical purposes, but has no impact on the business or processing. Relationship behaviors. Relationship behaviors control how certain actions cascade down to rows that are related to the primary table row through a one-to-many relationship. Behaviors maintain referential integrity and can prevent orphan records from being left behind. Types of behavior and description. Parental behavior. All actions use cascade all behavior. Referential behavior. Assign, share, unshare, and reparent use the cascade none behavior. Delete uses the remove link behavior, and merge uses the cascade all behavior. Referential restrict delete behavior. The same as referential, except that delete uses the restrict delete behavior. Custom. Individual behaviors can be assigned for each action. If choices match any of the other types of behavior categories, the value will change to that type of behavior value. Important. Defining relationship behaviors is important because the cascading of assigned records can cause related records to be assigned. If in doubt, set the behavior to referential and restrict. Alternate keys. Alternate keys are used in integrations to reduce the need to perform a query to find a record. By using an alternate key, you can update the row without knowing it's GUID. Alternate keys are excellent for using in retrieves and updates, can contain decimal, whole numbers, text fields, dates, and lookup fields, can have up to 5 alternate keys for each table, creates a nullable unique index behind the scenes to enforce uniqueness for the key. When a key is created, the system validates that the key can be supported by the platform. Diagram best practices. When creating ERDs for Dataverse, you should avoid data duplication. Every piece of data should have only one home, rather than duplicating the same data between multiple tables. Functionality like quick view forms and displaying related table data in views should be used. Use the ERD relationships to review and identify potential cascading behaviors that could impact business logic. For example, with parental relationships, permissions like assign, share, unshare, reparent, delete, and merge will automatically happen to related records when a parent record is updated. Next unit, best practices for Dataverse. Best practices for Dataverse. Data modeling is a science, and data modeling professionals and established standards for data modeling do exist. To be effective with Dataverse data modeling, you don't have to be a professional data modeler or use specific tools. Popular tools like Microsoft Visio can be used to quickly create basic entity relationship diagrams, or ERDs, that visualizes the relationships and flows of data between tables. This unit focuses on general best practices for data modeling for Dataverse deployments, including data models should be updated continuously during a deployment. Frequently, a data model is designed at the beginning of a project, but it's important that the design process doesn't stop at that point. As you go through the deployment, new columns and tables will be added. You need to capture these new columns and tables in the data model and then make it a living data model. Additionally, you should recommend to customers that they continue to update the data model as they enhance the system. Use established tools to help you start. Community tools that are available with the XRM toolbox that help make it easier for you to quickly generate ERD diagrams of your Dataverse configuration. These tools include the UML diagram generator and the entity relationship diagram creator. After you complete configuration updates, you can generate an up-to-date ERD diagram. Don't include every table. Some core tables, such as activities, notes, and users, record owners, are related to nearly every table in Dataverse. If you include every relationship with these tables in your data model, the result will be unreadable. The best practice is to only include the primary tables that are used in your configuration in your data model diagram, and only include custom relationships with the user and activity tables to maximize readability. Data models should include tables outside of Dataverse. If you're integrating with other systems by using Dataverse data connectors or virtual tables, or if you're integrating with data flows outside of Dataverse by using an integration, this data should also be represented in your data model diagram. Start simple with the standard tables and then add custom table relationships to your data model. Experience should influence your data model. Occasionally, it can be easy to over-normalize your data, but in the process, you can make the application more cumbersome to use. Start with what you need now, but design the data model in a way that will support what we will be doing in the future. For example, if you know that you'll eventually need to store more details about sales territories, you can use a text column for territory now, which will make it more difficult to implement than if you use the territory table relationship. Plan ahead for what is coming. Out-of-the-box versus custom tables. This topic identifies standard out-of-the-box tables that are used in the configuration, along with custom tables and the purpose for which they're being used. This information matters because Microsoft Dataverse has many common tables and, as a general rule, a custom table shouldn't be created if a standard table already exists that addresses the purpose. The reason is because if you overload your configuration with many redundant tables, you'll negatively impact the performance of the system and you'll make the system more difficult to use. Having many redundant sounding tables in Advanced Find will confuse users. Each custom table should serve a specific purpose. Additionally, this topic will help identify tables that are most used and identify if you're at risk of overloading tables. Reconsider replacing standard tables with custom tables. Occasionally, makers consider replacing standard functionality with custom tables. The reasoning behind that consideration is that if the makers need a sales opportunity but need a simpler form, that the standard opportunity form creating a custom table might be easier. However, you should consider what you might be giving up by using a custom table instead of a standard table. Using an out-of-the-box table ensures greater alignment with the core platform features. Because more features are added regularly to standard tables, you can benefit from new features when they're released. For example, if you decided to replace the standard opportunity table with a custom opportunity table, you won't be able to use the Sales Insights add-in for Microsoft Dynamics 365 Sales and other AI features. Don't recreate accounts and contacts. When deploying Microsoft Power Platform solutions, you'll frequently track multiple types of companies, organizations, and contacts in the system. Some of these entities represent customer client organizations, while others might be support and advisory organizations, such as accountants and legal firms. Some entities might be miscellaneous types of organizations, such as trade associations. The most common approach to managing multiple categories of company relationships is to use the account table for all organization types and use a column such as relationship type or a custom option set to flag companies by their type or category. You can filter views based on the type of company, and business rules can conditionally show or hide columns and form components based on that type. The benefit from a standard integration with Dynamics 365 Finance and Operations apps by using the dual-write infrastructure, it's best to use the default tables and columns that are added by the dual-write core solution to your Dataverse environment. Another approach is to create custom tables for each type of company. One reason that is commonly cited is, I might need to use accounts for another reason in the future, so I don't want to customize the account table. Before recreating the account table as a custom company table, you should strongly consider what you are giving up by creating a custom table. Consider the following factors. Multiple addresses. The account table has a unique address capability that supports multiple addresses. The first two addresses are displayed on the company form, but these address records live in the related customer address table. While you can create a custom address table that is tied to a custom company table, recreating the unique logic where the addresses are stored in the related table and are displayed on the form and table views would require development. If you need multiple addresses, use the account table. Contact hierarchy. Accounts are the parents of contacts. Activities that are related to contacts will roll up to the parent account record. This hierarchy can't be replaced by a custom company record. You can create more relationships with custom company tables, but the standard account contact relationship can't be replaced. If the company has contacts with their primary company relationships to this type of company, or if you want to roll up activities from contacts to companies, use the account table. Standard map control. In model-driven apps, standard map control doesn't support custom company tables. Hierarchical relationships. Hierarchical relationships between parent-child accounts and the standard hierarchy visualization and roll-up of child account activities to the parent account only work with the standard account tables. Polymorphic lookup columns. Dataverse includes a special type of polymorphic lookup column called a customer column. This column allows a row to be linked to a company account or a contact. Marketing will not work. Marketing lists can only work with contacts, accounts, and leads, not custom tables. Microsoft Dynamics 365 Customer Insights journeys can send to accounts and contacts, but not custom company tables. Therefore, in almost every situation, the account table should be used for company records of all types with the following exceptions. Minor types of companies that aren't relational and have minimal attributes, consider a type of organization with no contacts, no address, and that only exists for lookup purposes. Unqualified or unverified companies that are imported from business cards or web forms that you don't want to pollute the account table with. For these situations, you could use the lead table. Repurpose system tables. Consider the scenario where you have a business requirement that is similar to opportunities, but it's not a true sales opportunity. In this situation, you might consider repurposing system tables or creating new tables. The following section explains factors that you should consider before repurposing system tables. Consider the future. The future of Microsoft Power Platform is moving faster than ever before, so using tables in non-standard ways can cause problems if Microsoft makes changes to the table that you're using. Also, if you choose to repurpose a seldom used system table, such as contracts, Microsoft might elect to deprecate that table in the future. Custom tables aren't deprecated. Additionally, if you repurpose a system table, consider what you might do if you later need that entity for its intended purpose. Customers who have repurposed a case eventually need case management and have had to address it with custom tables because the standard case table was already used for different purposes. Consider overhead. Many system tables have certain columns that can't be removed from the forms. For example, some columns on tables like opportunity, case, and campaign can't be removed from the form. While you can hide these columns, having several locked columns on the form can add overhead to your environment configurations. Consider the user experience. If your use case is less than 50% in line with the standard table functionality, a custom table will typically give users a simpler user experience than scaling down a more complex system table. It's also possible to add business process flows to any table, including custom tables, which can make a custom table user experience as good as or better than repurposing a system table. Avoid common pitfalls. Common data modeling issues include too many tables. Likely the tables are over-normalized. Too many columns on a table. Likely a separate table should have been created. Use the tools. Quick view forms instead of repeating columns. Avoid the yes-no data type. If more values might be added, or you need to store the values as unknown. Formatting pitfalls. You're endlessly stuck with data type formatting. Unused parts. Avoid building parts of the data model that you don't plan to use. Proof of concept. Dataverse simplifies your ability to create a trial environment, and it's quick to create tables and relationships. You can build proof of concepts to try out your data model and see what the user experience might be like. Next unit, exercise, model data. In this exercise, you'll be creating a data model for Fabricam to track visitors. Review the information presented about Fabricam robotics and complete the tasks. This could be completed as a small group as well.
In this exercise, you will be creating a data model for Fabricam to track visitors to a showroom and manufacturing site. We have provided you with a simplified set of requirements. Use them to draft a data model on paper, a whiteboard, or using your favorite tool. You should be focused on modeling the main tables and relationships and only worry about columns that are key to support the requirements. As you consider how to approach building a data model for Fabricam robots, keep a few things in mind. First, there's not a single right or wrong solution. Most of the time, a data model is the result of a negotiation. For me, I like to identify one of the main tables and then go on to identify related tables from the requirements. I try to find the center of the story. What is the data around which everything depends? Don't worry initially about what is a new table or an existing table. You may also find that multiple tables you identify may end up consolidated into a single table later on. Halfway through your data model, you may have a great idea for a completely different data model. This is why we use paper or a whiteboard, so you can draw multiple models and ultimately pick the best parts from each of them for your final data model. For this exercise, you'll have to be both customer and architect. You may also have to take some creative license and make some assumptions to fill in the gaps in the requirements. But even on real-world projects, we don't see all of the requirements perfectly mapped out for us in explicit details. Think about how the data model will influence the entire system and how it will evolve over time. How can you make it more future-proof? You don't have to solve every problem on the first iteration of the proposed solution. Try to think through logical collections of features that would go together and make for a smooth round of user adoption. You can do this exercise on your own or get a colleague to play the customer and have fun.
If you're completing this exercise independently, take notes. Put yourself in the mindset of both customer and solution architect. Draw your data model, put pen to paper, actual pen to paper, or virtual pen to paper, and evaluate options. Consider bigger picture items. If you build this data model, you'll have to design security and relationship behavior too. Will your ideas still work? If given the opportunity, share this assignment with colleagues who are also architects and seek their feedback to your data model. Requirements. You're building a solution for Fabricam to track visitors to a showroom and manufacturing site. Some of the visitors are potential purchasers and some are there to see the magic of the robots working. Requirement 1. Visitors must have a reserved spot to gain access. Requirement 2. Visitors invited by sales staff must be tracked to a sales process. Visitors just touring for fun aren't tracked to a sales process. Requirement 3. Visitors can bring guests. Requirement 4. Each visitor must have a photo taken upon arrival and associated with their visit. Requirement 5. Each visitor must sign a waiver of liability each time they visit, and you must store their signature and date time of acceptance. Requirement 6. Each primary visitor is assigned an engagement tracking device that tracks their location in the manufacturing area and showroom. This is for safety and for improving the tours. The device stores the data in its own cloud service that offers both bulk export and API access. Requirement 7. You must allow for the tracking data to be viewed in the sales process user interface used by the sales staff. Requirement 8. Marketing has asked to be able to view visitors by day, month, quarter, along with statistics on closing of sales after a visit. Tasks. Create a data model for the above requirements. You can sketch your data model on a whiteboard or paper. You can use a tool such as Visio. Example of a data model, your model should be for the above requirements. How would you handle reservations? Would each member of a group need a reservation? How would you handle storing of visitor photos? How would you handle repeat visitors? How would you handle storing of visitor waiver acceptance and signature? How would you accommodate for viewing of tracking data in the sales process? Did you use anything from the common data model schema? How would you handle marketing statistics needs? Other considerations. What connectors, if any, would be needed? How could you model the data differently than your initial proposed solution? What compromises did you make with the stated requirements versus your planned data model? What concerns do you have for the implementation of the proposed solution? What are the performance considerations? Does your data model lend itself to a good user experience in an app? Did you include the following influences in your data model planning? Security. data localization, data retention policy, reporting, customer roadmap, product roadmap, existing systems. Next unit, architecture of Fabricam data model and devices. Architecture of Fabricam data model and devices. In the following videos, the team discusses the requirements. We start with getting to know Fabricam and how we would address the overall data model.
Hi, Julie here, and I'm here with Sheila and Scott and Dave, and we're going to talk about architecting the database model for Fabricam. So welcome, guys. Thank you for joining me for this chat.
Thanks, Julie.
Glad to be here.
We've got Fabricam robots, and we need to help them track the visitors to their showroom and manufacturing sites. So Scott, how do you like to start a data model?
Well, you just talked about visitor and visit. Those are the two things that seem to be central to the whole data model. So I kind of trying to latch onto the thing that we can really put at the center and then move out from there. So, we're going to have a table to represent a visit. And then each of those visitors is going to have to be represented in some way. The first question that kind of springs to mind is, of course, with a visitor, in the common data model, we've already got a contact, right? So, that contact has already got the ability to collect data on name and all of that kind of information. So, first question would be, are we going to use contact to represent the visitor? Is there any additional information that perhaps we'd be collecting about a visitor that we don't want to store on a contact, or maybe we don't have the information necessary? And so the requirement that springs to mind is the fact that you may have a primary visitor, and then you'd have guests, visitors, and I'm guessing.
Well, yeah, and
perhaps
that guest is the problem, right? Because do we want to track guests as contacts? We really need to think through that a little bit.
Yeah, exactly. Especially these days where you maybe don't even have there's the waiver that's being signed, but you may not have the ability to even capture information from a Data Protection Act perspective.
Sheila, I know that we had talked previously, but what if there's like a field trip of kids that comes to this manufacturing site to watch them make robots? How would we handle like kids and data about them?
Yeah, I think the key with that is just understanding what are we allowed to capture, what do we need to store, what are the pros and cons of putting those types of things into something like a contact record versus a separate record that maybe could even associate with a contact. What would the user experience look like based on what you decide to use? If you're using something like a Power App to expose that data model. Those are all the things that I usually consider when I'm deciding, because deciding on whether a person should be represented as a contact is very common to problems that we encounter.
Right, because if it looks like a contact and it acts like a contact, is it a contact, or is there that too much stuff to put inside of a contact, right?
Mm-hmm.
And Sheila, what you just mentioned there about user experience, I think is really important, because if you think about if this was just going to be a model-driven app, then if you're creating a visitor separately to a contact, then as far as the user's concerned, that's sort of two separate steps. Whereas if this was a Canvas app or a custom page doing this kind of checking in of visitors, because I'm guessing the experience that someone's on reception going to be checking these people in wants to be like highly optimized. So maybe it's not an issue because, behind the actual, the code that can actually create a contact separately and to a visitor unbeknownst to the person doing that check-in. But of course, they're still going to have to search to see if they're an existing contact because they may have visited already. So
and
they
then
could
that
be
might add some friction to that user experience, right? Because then we're adding that additional information, or maybe there's a slight lag and we don't have that duplicate detection right away. And so we're creating friction for our users.
Well, and I think you nailed it, Scott, when you talked about the visitor and the visit. Those are probably two key things, because we do have to track each of the specific visits, because they may have come multiple times, especially in a sales scenario. They may be looking at different details of the product as they're evaluating.
So we've got some more requirements here we need to figure out. And for these, I'm going to go ahead and read them verbatim from what we've received from the client. So we've got a requirement that says each primary visitor isn't assigned an engagement tracking device that tracks their location in the manufacturing area and showroom. This is for safety as well as for improving the tours. The device stores the data in its own cloud service that offers both bulk export and API access. So Sheila, how do we start taking that apart into something that's usable?
Oh, I have so many questions. I am unclear on how are we consuming this data. So that would drive a lot of different decisions around what I would propose. I will say that due to the fact that IoT data is very large, I'm assuming that's what we're using as far as a tracking device goes. Our Dataverse environment is not conducive to what we call big data solutions as it stands. So that's something that we would need to consider.
Dave, where would you go with this?
Well, I think you need to look at the benefits of bringing it into the ecosystem versus out. And that's kind of where Sheila was heading with that. And, you know, with the connector technology, with the virtualization of items that you can do, we have some definite options. And I tend to look at latency that we have to have between there. And it comes back to what Sheila was saying and how we're going to use that data. But we have some definite options with connectors, especially bringing it into apps later on.
Anything to add, Scott?
Well, of course, there may be some post-processing that may be needed to be done as well. So maybe we need to be massaging that data before it comes in as well, you know, to align it with positional information. But as far as Dataverse is concerned, we're going to have a table to represent the actual tracking a device and where it's located in terms of the factory, the warehouse, that kind of place. You know, maybe some of those tracking devices they're already assigned, so you can't pick them because they're assigned to someone else. Maybe they're inactive because they've got some bug on them, or you know, something that needs fixing, and they may move even between different locations. So we're going to have to store like a time in and a time out to be able to correlate the actual IoT data or what it is
Exactly.
with the actual data in the visit.
We need to connect that to the visit essentially, so we are able to accommodate that tracking.
Yeah.
So we've got the data that comes from the device, which probably is too much data to think about bringing in. We need some answers first. But we also have got some kind of intersect entity between the device and the visit that we're talking about for tracking purposes.
Yeah, I think you're going to have to correlate it somehow. So
Okay.
that would be a good way to do that for sure.
Yeah, and that may even just be down to timestamps. You know, it might be like, well, we know that this tracking date, we've got 5,000 data tracking points in one day, but we know between this time and this time it was assigned to this visit, between this time and it was time assigned to a different visit, you know, so that will exclude all the tracking data that is just sitting in a cupboard somewhere, that kind of thing.
Right. Okay. That takes us on to our next requirement, which is related, where again, I'm going to go ahead and read it verbatim here. You must allow for the tracking data to be viewed in the sales process user interface used by the sales staff. Any changes in our approach so far?
No, I think the key thing it highlights is the idea that what you may do is summarize that visit for the key points. You may want to capture the 10 places in the factory that they stopped and how long they spent at it, and not show them the detailed telemetry.
That makes sense. Yeah, I would assume, I'm assuming things here. Don't like to assume, but I'm assuming that yes, there's some derived intelligence that we're trying to take from this visit. And I would assume that we would have some aggregate information via some kind of, you know, calculation or something that we would present to the users rather than just showing them, you know, an end-to-end walkthrough of how that visitor traversed the showroom.
I want to ask the salespeople what kind of decisions they're trying to make on this data, because a salesperson is not the sort of person I would expect to be browsing just data randomly. I mean, they're going to want to say, well, okay, well, what worked, what didn't work, how can I make a better decision next time when I'm sending out invitations, or maybe when I'm giving the people a tour of the factory or whatever. so that they can then drive sales ultimately, I suppose.
No, it comes down to which do I give more discount on versus which can I charge them full price or a premium.
There you
Could
go.
be, absolutely.
Yes.
Yeah.
Okay.
Next, the team discusses how to address the information received from the tracking devices and how to include that in the sales process. Next unit, report data and handle primary visitors. Report data and handle primary visitors. During this video, the team reviews reporting needs and how to include that with out-of-the-box resources.
So our last listed requirement, marketing has asked to be able to view visitors by day, month, and quarter, along with statistics on closing of sales after a visit. Anybody want to jump in on that one?
Well, this sounds like a classic sort of data warehouse Power BI type requirement here, from an after the effect. It's not going to be perhaps real-time information that people are looking at. Maybe that's what we were talking about before, although real-time obviously is not something that's necessarily always needed, but this is definitely not going to be real-time. This is something that's going to aggregate over weeks, months, etc. And so therefore we can afford to have data that's delayed by whatever, and then do all of that processing in a data warehouse, and then do the massaging to make sure that we're giving them the information to make those decisions.
Yeah, I
Well,
would
I think,
just,
go ahead, Sheila.
I would challenge that a little bit in that I would ask, what are we actually trying to report on? Because introducing something as complex as a data warehouse to a solution is a big decision to make. If those statistics that they're looking at are just, probability measurements that are based in what we call our transactional data, and all the rest of the splicing is very much just tabular table type of filtering, then maybe we, think about it from that perspective. The other thing I would consider, though, that would be more of a warehouse pro is, how long are we retaining this data in Dataverse versus archiving it and providing all of that intelligence through historical tracking and whatever those statistics are. I want to know what's in those statistics.
Well, and the important thing that we have to remember is that if we want insights come from data that you are able to do things with. We need to make sure to collect the data. Otherwise, we won't be able to do the reporting later. And I agree with you, getting to the bottom of it. A lot of this will sort out as we get into the detail of the requirements and what fields and columns end up on the underlying data stores.
Right. So this requirement could be something as simple as making sure they have a super swanky Power BI dashboard available, or introducing a whole lot of other overhead if that's what they need. Is that fair?
Yeah, definitely.
Okay, awesome. So who wants to go build a data model and who wants to go visit and watch the robots?
I'm
gonna go
with the
visit the
robots.
Yeah. Scott, I guess you and I are working.
Next unit, handle visitors' waivers and photos. Handle visitors, waivers, and photos. Now we need to evaluate if the visit is a custom activity or a custom table. The team discusses not only the requirements as presented, but also some questions that need to be asked of stakeholders to better understand the requirements. As we discuss primary visitors and guests, the user experience comes to the top of the discussion.
So
Yes.
I want to jump into talking about that visit. I'm going to grab onto that because I think we have a decision to make there, because what kind of information will we have on the visit? We're going to schedule it. So
Yeah.
it's got a start time. It probably has an end time. It's got related parties who's attached to that visit, whether they're, a contact or another record, that's fine. Is visit a custom activity or is it an appointment? How do we handle that visit scenario?
Yeah, that's
Any
another
ideas, Tina?
common data model scenario where often when you're dealing with some form of an event or something like that, it can commonly be considered to be an activity. But as we were just talking about with context, a lot of times there's benefits to reusing and repurposing these baseline things. Sometimes there's a lot of cons to it, though. So I don't know if anybody else has any idea of what would be a pro or a con of using the out-of-the-box activity. We're making a custom version of that, basically.
Well, one of the pros would be it would show up in the timeline very easily, but the negative of that is the security model, because they can't get the granular security on the activities.
Yeah.
And that probably would make sense because it's such a specialized table that we could keep it as a custom table rather than a custom activity. But I don't know if anybody else has thoughts.
Yeah, I mean, the security I find is always causing challenges with the activities, reusing making a custom activity. But not only that, the fact that, as you mentioned, it's going to appear in the timeline. Sometimes you don't want them to appear in the timeline by default, especially if it's a sales process that is just going to cloud the problem. And so I tend to approach custom activities to say directly from a user interface, what benefit is it going to provide? So I start with saying it's not going to be a custom activity, and then start to say, well, if we made it a custom activity, what advantages would that actually give us? And then start to say, do the advantages outweigh all the challenges with all the security and the fact that you can't really filter it out by default in certain circumstances, etc.
So I think that that's maybe a decision we kind of have to hold in a draft form until we find out more about the security needs,
Yeah.
right?
And-
Because
and
there
you
may be
also-
sensitive data that we find as we go through the data modeling exercises, the security modeling exercises. We may find out that there's sensitive data that we need more granular control.
Yeah.
Do you think? So
Definitely.
the last thing I wanted to chat about is those waivers and photos. So our requirements tell us that every visit, every person has to sign a liability waiver. Makes sense. It's a manufacturing place, and they need to take a photo. Where are we going to put that information? How are we going to, from a user perspective, how are we handling that? What do you guys think we should do about those two specific requirements?
Well, I think first we really need to nail down, do we need to capture it for each time, or do we have some leeway on that? Like with the photo, people don't change that often. Could we capture with a photo and put it on the contact and just retain that? And as long as there is one, use that for each visit.
And then, if you do that, it really does then force us down that route of having to have a contact for every single visitor. So you're always going to have to link it to a contact, which may not be a bad thing, given the fact that we want to be able to know if every single visit, we want to be able to collect the visitor has signed a waiver, the time that they actually arrived, potentially any other information that we collect about them at that point in time, but then link them to a single record to say, I can open up a contact and then find all of the times that individual person has actually visited.
Sure.
But I think we do need to go back and ask.
And I think that's the key as architects. Oftentimes we encounter requirements that if we took them verbatim could introduce a lot of complexity to a system. And oftentimes it's good to just ask why do we need this? Why do we need a photo for every single visit? What is the benefit of that? What are we using that for? And just really understanding the purpose for that before we go and build this, fancy solution for it.
Right. Oftentimes it's just because we need to have a photo, but it could also be it's inventorying the people who are on site right this minute. So if somebody goes missing, we know what they're wearing today. So we can go find them easier, right?
Yeah.
It's the cruise ship mentality.
We do actually capture there's that requirement to capture the signature. So in a sense, we still do need to have an image that we're capturing for every single visitor for each visit. But obviously from a storage, especially these days with Dataverse storage being not, is not, it's at a premium, right? So we do have to take that into consideration as well.
But also files get into file storage, which is less expensive. So that's a benefit also.
Yeah, that's a good improvement that we've seen recently.
Okay, so I think we casually decided that we're probably going to be using contacts. We may have some considerations around what if the visitors are like kids or some special circumstances where we really don't need to keep a permanent record of an individual, but we're probably having contacts. We've got a visitor that's related to a contact. We have a visit, and we're not yet sure if that visit is a custom activity using something from the common data model, or if it's a custom table that we build out that resembles that. We still need some more information. Is that fair?
Yeah, definitely. And I think if you look at those requirements that we have, we're talking about the sales process. I think with the contact, again, it starts to lead me further down that route of a contact, because then you're talking about customers and accounts. And that really then does start to marry in exactly with things, that the salespeople are going to be dealing with on a daily basis.
Especially
we
if you
don't know
bring
what
in
the sales
Dynamics
process is.
365 sales into that picture.
Yeah,
Right.
that's true. Yeah, sorry,
So-
I think you both were talking at the same time, so maybe.
So yeah, we don't know what that sales process is. We don't know if it's Dynamics. We don't know if it's a competitor. We don't know if it's Scott's custom sales process, right?
Yeah, I suppose that's the thing. Yeah, exactly. I just naturally, when I saw that requirement, I know Dynamics 365 sales, and I naturally assume, right, okay, let's use the opportunity and all of those kind of parts of the sales hub. However, of course, yeah, I mean, they may be building this out as a custom, or they may even have a completely separate system altogether. So yeah, we do need to go back and confirm that.
Right.
But
That's
even
why it's so
then-
important to understand the peripheral systems that you're interfacing with and the data that's available when you're architecting.
But even then, the concept of a sales process is independent of a system. So I think your argument, Scott, still holds some weight regardless
Right.
of where that is.
Right,
Yeah.
because the model that we're working with can work with Dynamics if that's what we have. It can work with Scott's homegrown customer management system, and it can work with any number of third-party systems that we all know are out there.
There was one thing that also sprung to mind for me when the primary visitor relationship versus that additional guests requirement. Because if you think about from a user interface, if you open up a visit, then you're going to look and see, okay, well, there's the primary visitor and there's the additional guests. And I was wondering, do we need to store the primary visitor as a sort of like a separate relationship, or do we just simply bundle it in with a one-to-many relationship and then have like a flag on that visitor to say, right, they're the primary visitor? Because I think that's really down to the user interface benefit that we may get. Because if you have it just as a single one-to-many relationship, then in a model-driven app, of course, it's from a user interface, it's going to look really neat because it's just going to be a single grid. However, it's going to make it harder to create a record, because you'd have to obviously create a new record and then mark it as the primary visitor. And then you maybe have to have some server-side logic to prevent you having multiple primary visitors. Whereas if you have a separate relationship, which is just a single lookup, a many to one, then it's almost like there's a constraint built in to the relationships that prevents you from having more than one primary visitor.
Well, and I think the key to getting to the bottom of that is understanding what the frequency is of visitors versus just somebody coming as the primary buyer or purchaser.
Yeah.
So in using the technology we have available, we have a lot of options, right? So from a Canvas app perspective, we can mask all of that busyness that's happening in the background and give them a fairly smooth experience.
Yeah, definitely.
Okay, well, thank you so much, guys, for this discussion. We've got some more requirements to circle back to. We'll see you at the next video.
Next unit, Example Data Model Solution. Example Data Model Solution. Microsoft Dataverse is a flexible data repository that can solve business problems in multiple ways. There isn't a single right way to data model this solution. The following is an example of how you might approach solving this set of requirements. compare the example data model to what you designed and review the differences.
So let's take a few minutes and go through our proposed data model for Fabricam robots. After the team discussed all of the requirements, this data model is what we scribbled out on a whiteboard. Let's dive into more details now on the proposed data model. The visit and the visitor are the center of our story. Visitor rows will contain data that is just about this visit, such as the signed waiver and the visitor photo. And the visit table is a custom table, not a custom activity, and it will keep track of the purpose of the visit, visiting parties, reservation information, and visit details like check-in time, check-out time, which tracking device has been assigned to the visit, and so on. Visits will have a relationship to the sales process. We don't yet know much about the sales process, so if it's Power Platform or Dynamics, the connecting of these tables will be very straightforward. If it's an external system, additional effort will be needed to connect that data, but with hundreds of connectors and custom connector options, it shouldn't be much of an issue. This is definitely an area where we need a little bit more discussion with the client. Each visitor will be tracked in the contact table to capture details such as email, phone number, and so on. In general, we think that contacts will reference an account row, and both of these track to the sales process. Our requirements didn't explicitly state this was the case, so we've made an assumption. We'll have to confirm this with the client later on. And the data provided to us from the tracking device will be consumed as a custom page in a Power App via the API. This is a good area for us to try out a proof of concept, and we should be prepared to adjust this as necessary. We need more information about this particular requirement, but this is the recommendation we have at this point with the information we have available. Now, compare this data model with the one that you've drafted for the requirements and see where they differ.
In addition to the proposed data model, our architect suggested the following options. Upon evaluation and additional information from Fabricam, visits might be a custom activity table. Not every visitor should be a contact record. If the visitor has low probability as a customer, just here to see the robots, then keep the contact table cleaner without the other visitor records. Keep the contacts dedicated to the sales process. IoT devices, such as the tracker mentioned in the requirements, can quickly produce massive amounts of data. We're basing our model on the assumption that the provided API allows us to use the data relevant to our purposes. If that isn't the case, a much deeper discussion would be required. Even when it seems like the requirements lend themselves to a certain path, it's likely there isn't a single right way to meet those requirements. As solution architects, it's important to evaluate the requirements with an eye on offering the simplest solution that meets or exceeds the requirements, while providing a secure environment that users are delighted to use. Next unit, check your knowledge. Answer the following questions to see what you've learned. Because account and contact system entities are easily recreated, is it a good idea to recreate them across several custom entities to get the exact system that you need? Yes, you should always recreate custom entities whenever possible. Yes, recreating custom entities is harmless. No, in almost every situation, accounts and contacts should not be recreated. No, custom entities don't provide value. I'll say no, in almost every situation, accounts and contacts should not be recreated. You are creating a solution for a not-for-profit system. You need to move quickly with the build. What should you use? Proof of concept, non-profit industry accelerator, create custom tables, XRM toolbox. I'm going to say non-profit industry accelerator. Which data type should you use to create a column that has 3 values that the user must select from, and the values change every 3 months? I'm going to say lookup. And there are the answers. Let's go to summary. Summary. In this module, you learned about the solution architect's role in data modeling with Microsoft Power Platform, including data modeling influences, data model strategies, where to store data, data types, how to define relationships. A good data model is essential because it forms the foundation on which you build your apps. The data model drives your app interface and design. Problems with your data model are difficult to correct after apps have been composed by using the model. Next steps. Learn more with the Design Data Models for Dynamics 365 Solutions module. I hope you found this useful. Give the video a thumbs up and subscribe to the channel. Thanks for watching.